Hey guys, welcome to my channel. And today, as you can see on the screen, we are going to be building a hand tracking app in Python. So let's get started. So first of all, let's create a virtual environment in which our Python app will live, right? So Python 3-m venv, then the folder. All right, so it created a venv folder, which will basically be our virtual environment, right? Now we have to activate that virtual environment. So for that, we're just gonna do source dot slash venv bean activate, and this basically activated our virtual environment. Great. So now the library that we are going to be using to build this app is going to be the MediaPipe, and the second is going to be OpenCV. So let's get started. For that, I'm just gonna do pip install MediaPipe and OpenCV. Right? Yeah, so I typed the wrong package name. So it is MediaPipe and OpenCV Python, right? Let's let them get installed. In the meantime, I'm going to create a main.py, which will be the main file for our project. Okay, so we have the package installed. First and foremost, I'm going to define a function called main, define main, right? And then here I'm going to say if name equal to main, just run this, right? And let's try running this. So Python main.py, right? You can see the hello world, right? Now let's import our packages, which we're going to be using. So we are using, again, we are using two packages. One is MediaPipe and the second one is OpenCV. MediaPipe is basically for detecting our hand. It is a library by Google, right? So we're going to be using that. And then we are going to be using CV2, which is OpenCV, which is very popular. And we are going to be using that for, reading the feed from our camera and then, showcasing that to the user, basically who's going to use our app, right? So first and foremost, I'm going to import CV2, which is the OpenCV package. And then I'm going to import MediaPipe. This name is as MP, right? And now let's define a variable called MP hands, which will be equal to mp.solution.hands. And basically what it do is it detects our hands, right? And then we are going to be importing MP draw, which will be responsible for drawing, those connection as you have seen in the start of the video, right? So MP draw, MP dot solutions, solution dot drawing utils, right? Next will be our capture. So capture is going to be our the camera. So I'm going to say cv2.video capture 0. I'm going to use 2 because I want to use my camera, not my laptop camera. So I'm going to use 2. And every camera has indexes. If you have multiple cameras, then there will be multiple indexes. But for now, I'm going to keep it 2. Right? And then we are going to be setting its resolution. So the resolution and the width. So cap.set 3 is the width identifier. And then we have 4, which is the height identifier. So we're going to do 720, right? So this is going to be the capture, the camera, right? So now let's start our hand tracking, right? So I'm going to remove the hello world here. Right now, let's first start by showing the camera feed, right? Let's do that. Firstly and foremost, we have to get the frame, get the image from the camera. So what we are going to do is we're going to run a continuous loop here by true. success is that we are able to read from the camera. Image equal to cap dot the capture read, right? Also, I have to define an attempt variable here. I'll explain you why we need this in a second, but we're just gonna run a loop here again. While not success and attempt is less than 5, sleep for like 0.1 or 0.2 seconds, and then again, read it, and then make, uh, and then basically make attempt plus 1, right? So, we are looping over the attempt, and then we say if not success, right? So if not success, we are going to print and say fail to read frame, whatever, break, right? The reason we are doing this attempt and success thing is because sometimes the camera feed takes time to load, and the program will basically exit, right? Because it will not receive any success, and it will just exit and will say it's not working. And that is why I'm adding this attempt, which will try like 5 times to read from the camera, and between each like attempt there is an interval which is 0.2 seconds, right? So that's the thing. Now we got the let's say we are able to like get the feed. Then what we're going to do is we're going to flip the image. The reason we are flipping the image is because when you are hand tracking, it's much more easier if the image is flipped, which is like mirrored version of your camera. So image 1, and then we are going to open a window which is going to show that image, right? So image show, and the title of the basically the window, which is going to be this, an image. And then we're going to do if cv2 dot wait key 1 and break. So this is basically will break if the user basically press q on the screen, right? And after that, we are going to release the capture, um, and then destroy all the window. This will be outside the while loop, right? And then we're going to release and destroy the window, right? Now let's try and run this thing. So I'm going to go here, Python main.py. All right, you can see the feed, right? And it messed up my, view here, but that's okay. Let me fix that up. So, okay, so great. Now let's actually start the hand tracking, right? So for that, we are going to do a couple of things here. So we are already reading from the camera, and we are already flipping the image, right? Now we have to actually detect hands and draw those hands in the, in the video. So let's do that. First and foremost, we're going to get the height and width from the image. So height width from image.shape, right? Then we are going to get the RGB version of it, because the OpenCV gives you a BGR version, but the MediaPipe library use RGB version. So we need to convert. So cv2 dot cvt color, and then image, and then cv2 color BZR to RGB. We forgot one thing, and then we need to actually initialize the ampy hands function, right? So what we are going to do is with ampy hands dot hands, right? Firstly and foremost, we're going to define the number of hands we can detect. So I'm going to say max number of hands is going to be 2. Then minimum detection confidence, like what should be the confidence? The higher the number, the accurate it will be, and the lower the number, it can detect, you know, anything. So, and then there will be tracking confidence as well, which is, let's say, keep it 0.7, to track the hands when they're moving. Right now, all with all that as hands, and then we're going to move the whole while block inside it. Now, max number of hands 2, minimum detection confidence 0.7, and then track them around, which is 0.7. We have the RGB, right? And then what we're going to say here is results equal to hands. This is the instance. So hands dot process that image. So it's going to basically do it image or image, right? So hands dot process that um, image, right? And basically this will give us all the data that we need to draw and track those hands, right? So once we get the results inside this, we will get multi-landmarks. So if results dot multi-hand landmarks. So multi-hand landmark is basically, how many hands there are basically. So for hand landmarks, for each hand landmark in results dot multi-hand landmarks, right? So 4 hand landmarks in results dot multi-hand. So if there is a result, and then for each hand landmarks, we're going to draw the landmark into the frame, right? So let's do that. So mp draw landmarks, where we want to draw it into the image, what we want to draw, the hand landmarks, and let's just do this, and I think it will be fine. Let me see if it will be okay. Let's see if this works. So I'm going to go here, run the script. All right, so you can see the pointers, right? That is cool, right? And you can see all the pointers. Great, so it's work. I'm going to close this. Now you can also specify if you want to basically draw the connection between the hands. So let's do that. So mp hands dot hand connections. Let's say, and rerun this, and you can see the connection, right? All right, great. Now all of this is cool, but what I want to do is basically show, which is like the thumb, index finger, ring finger, and all that, right? So let's do that. Okay, so finger. So we're going to define a dictionary fingertips, and we're going to say, let's say thumb is on the landmark, right? So hand, we have the hand landmarks, hand landmarks dot landmark 4 basically. So this is how basically it keeps the MediaPipe library keeps track of each finger. So let's say, so it's like hand landmark dot landmark 4, and then we have index at landmark 8, and then we have middle at 12, ring at 16, pinky at 20. And that's how it's basically define all the fingertips, and basically you have access to everything, right? And the reason is basically the points, right? So you have like those red pointers, and that's how it's calculated. And what we are going to do is we are going to run a loop and then show that um, basically on top of each finger. So for name and the landmark in fingertips dot items. So firstly and foremost, x and y is going to be int landmark x into w, landmark y into the height, right? Which is the image shape. And the reason we are doing it, so it basically adjusts itself according to the camera, basically, right? And then we are going to put a text there, cv2 dot put text, where in the image, what text to put, the name of the, whatever, the thumb, the index, the middle, the ring and pinky, right? What should be the coordinate? X, Y minus 10, because we want it slightly at the top of your finger, right? What font we need to use, right? CVT dot simplex. Then what should be the um, thickness? We're going to keep it 0.5, let's say. Then what should be the color? We can keep it white. And then at the end, the thickness of basically the line height, right? Basically put a text in there. Let's try to run it and see if this works. Okay, so you can see the text, right? At each finger. So, thumb, index, middle, ring, pinky here as well. Great. But I also want to distinguish it more. So what I'm going to do is put a green circle at top of each finger. So it's like much more prominent than, all those red dots, right? So we're going to do this CV2 dot circle. We are going to put it in the image. What should be the coordinate? X and Y. What should be the radius? 5 is okay. Thickness. The color, we are going to do, let's say this. Let's try this out. And what is this? The color, the minus one. Minus one is basically, it will fill the whole circle, right? And we'll just go here, run this again. And you can see those circles, right? And yeah, I mean, that's how you can build this hand tracking app in Python. So this is the first part, and in the second part, what I want to do is basically, using this tracking, I want to do some kind of actions, right? Maybe like pinch. When you do pinch, you select something or something happens in your computer and like control things using the gestures, right? So yeah, stay tuned for that, and I hope I'll see you in that video.